Now, welcome to lesson 3 of my refresher course. Today I'm going to be talking about algebraic fractions and then rational equations. So basically equations involving algebraic fractions. So just as a quick warm-up, maybe look down through these 4 examples and don't do them out or anything like that, but just have a quick think which ones that you think are going to be correct and which ones are not going to be correct. So I'll just give you a moment just to look at those 4 examples. Okay, so where to start? So maybe I'll go to try find ones that I think are clearly incorrect to begin with, right? So something where like it's obviously not correct, right? Maybe there's some of them we don't know. We have to do some algebra first before we can check if they're correct, but there's ones that are going to obviously be correct. Now, this one here this is obviously incorrect, right? Because what we're having here is um, the x here can't, if it was like x squared over x, then we would get x, right? But like, where's the 1 over x bit? Like, how's this 1 coming out? So that's definitely not correct. This one here is also definitely not correct because, you know, yes, if it was 2x over x, then the x's would cancel and you get a 2, but there's this other piece left over that we can't just simply ignore, okay? So these 2 are incorrect. This one up here is correct, as it turns out. So that's x squared minus 9 is the same as x squared minus 3 squared. And then x squared minus 3 squared is going to be x minus 3 by x plus 3. That's just the difference of 2 squares. And I hope you can see that, like, you keep repeating stuff from previous sections. It's not like you do something and you leave it behind, but you carry it with you through the whole course. And we have the same thing top and bottom. And this is, you know, like if we had a fraction, let's say 2x over 2, we could cancel off that 2 because it's, you know, it's just this is just 2 over 2 multiplied by x, right? So we can always manipulate fractions like this by separate because everything's multiplied, right? So we can just separate stuff out. And 2 over 2 is just another way of saying like 1, isn't it? Like 2 halves is just 1. So this is just 1x, which is just x, right? Okay, so we can cancel this stuff out. In the same way, we can cancel this out if and only if, so sometimes they write like that, if and only if fx is not equal to 3. Just take a moment to try to think to yourself why x cannot be equal to 3. So what we're seeing is we're seeing the same kind of logic being applied here in a different situation. Almost exactly the same, except we just need to add a little modifier. We just have to say, just with the special proviso that x cannot be equal to 3. And the reason is if x was equal to 3, that would mean that x minus 3 would be equal to 0. That would mean that we're dividing by 0. We can't divide anything by 0 because just think about having a cake, you know, divide by 4 means split it into 4 pieces. Divide by 10 means split it into 10 pieces. I was trying to draw 10 pieces, whatever. Dividing by 0 does not make any sense, right? So it's just not a sensible thing. We can never divide by 0. Okay, it's just one of the rules. And then this example here is also correct. We'll see that in the following slides. Okay. So as I said, an algebraic fraction works exactly like a number fraction, but the denominator can never be 0. So basically what we're going to try and do when we look to simplify algebraic fractions is we're going to have to do this factorization step on the top and bottom. So yesterday we were doing factorization when we were solving polynomials. Yesterday we were doing factorization when we were solving polynomials. Today we're going to use factorization when we're simplifying algebraic fractions. And, you know, obviously, as I said, the denominator can never be equal to 0, and then we're only going to cancel the common factors. So we're going to cancel stuff that's on the top and on the bottom. Okay. So Okay, so let's start looking at some examples. So just the same as like last few days, we're going to have some algebraic expression, and we're going to look at how can we factorize this thing. So if we look at this top line, so we're going to sort of treat this as two sort of separate questions at the same time. So above this line, I'm going to work here. Below it, it's like two separate questions, right? So I have a square, I have a minus sign, I have a number. So this is looking like the difference of two squares. So this is x squared minus 4 squared. And on the bottom, I have, it's not a trinomial, but we see there's an x, which is a common factor, x times x minus 4. Then we have x, on the top line, we have x squared minus 4 squared. So this is going to be x minus 4 by x plus 4, all over x times x minus 4. And remember, you have to sort of train yourself so that when you see brackets, you're thinking that this is just a number, right? So if this was like 2 times x plus 4 over x times 2, we would have no difficulty in recognizing that there's a 2 top and bottom so that we can cancel that 2. So because we have brackets around something, you see that bracketing, it's like, I think people even say that sometimes. I mean, bracketing, like putting everything into just like one sort of category, right? So putting brackets around this makes it a single number. So it's just like canceling off the 2. So we can cancel it if and only if x is not equal to 4. In that case, we would be dividing by 0, so we can't do it. So this whole expression here boils down to x plus 4 over x, and we've simplified the expression. And this is true if and only if, which you can also do with this nice symbol, an arrow going in both directions. X is not equal to 4. Or you can just say it in words, if x is not equal to 4 or whatever. Okay, so now we have this business with fractions. And this is a kind of an example of like, it's an example of how you can take something that you've learned much, much earlier when you were learning maths and apply it almost in exactly the same way in this more like advanced situation. Okay. And let me just take the example over here, like 1/2 plus 1/3. Let me just check something for a second. Just going to check. Okay, great. Sorry, just want to check something. Okay, so if we were adding 1/2 and 1/3, like, this is like your cake, right? Let me draw that better. Okay, so this is like your cake. You're taking half of it, and then you're taking another cake, and you're sort of saying you're taking a third of it. And what's a half plus a third? And the problem is that we have a problem adding fractions when the denominators are different. Now, I know that you know this, but I'm trying to see what I'm trying to do is I'm trying to stop you from learning a new thing when we go to tackle this. I want to connect this to an old thing that you already understand. This is the discipline. This is actually what maths kind of gives you. So what I'm going to do instead is I'm going to take this first cake, instead of considering it as halves, I'm going to consider it as sixths. So let me divide this into 6, and we see that 1/2 is actually 3/6. So this is 3/6. And this one here is, well, let's just continue these lines. You see, this is now also divided into 6. This is now 2/6. And then when we go to add them, well, now because they have the same denominator, 3/6 and 2/6 is 5/6. Okay, so this is our template example. And we're going to be able to take this example, just look at it a little bit more deeply and apply it to this example here and every one of these examples of this type. Okay, how are we going to do it? Well, the question is really, how did we get from 1/2 to 3/6? How did we get from 1/3 to 2/6? And this is what we did. See, we had a half plus a third, and we're allowed to multiply fractions by another fraction and not change that fraction as long as it's the same number over itself. So I'm going to multiply this first fraction by the same number over itself. So it's just going to be multiplying by 1, so I won't change that fraction. I'm going to do the same here. What number am I going to choose? The other denominator. 3/3, 2/2. Okay, so you see this is just 1 and that is just 1, so I'm not changing the fraction. But when I multiply out, remember multiplying a fraction by a fraction, you just multiply the two denominators, you multiply the two numerators, you multiply the two denominators, right? So you have 3 over 6 plus 2 over 6. See? Okay, so we take the exact same approach over here. We're able to do exactly that over here. So let's just write this out. Again, if what I'm saying to you is super obvious, like that's good, right? This is what warm-ups are all about, like kind of doing familiar stuff again, just to kind of get you started, basically, right? So I'm going to have a line here, a line here. Okay, I'm going to choose a number over itself to multiply here, and a number over itself to multiply here. And remember, my objective is to get the same denominator. So what number is going to be here? Well, it's going to be the other denominator, x plus 1 over x plus 1. Why not just put brackets just to be safe, right? X over x. Why not just put brackets just to be safe? Okay, so now let's just do some, we've kind of now done all the hard work, so let's just multiply out that top line. That's x plus 1. I should have had brackets there, right? Over x times x plus 1 plus 2x over x times x plus 1. Now, in the same way as what we did down here, you see, we got this to be 3 plus 2 just over one single denominator, which was then 5 over 6. We're going to do that x plus 1 plus 2x over x times x plus 1. So this is 3x plus 1 over x times x plus 1. And I'm just going to leave it like that. We can't cancel anything anymore. We have no way of like, there's no point in multiplying this out, because remember, we do like to have things kind of factorized, because then they're kind of easier to deal with. Okay. So you see what I'm saying? Like, what I'm saying is that, like, don't learn a new thing. Like, if you're able to take an old thing and recycle it and apply it in another context, even if it's more complicated, it looks more complicated, that's great news. You want to limit the amount of new things that you have to learn. So if you have a way to connect a new idea to a previous concept that you already got, definitely use it. If you have a way to have a method that works in one place that can be used in another, this is really good news, because it's less space being taken up in your brain by additional facts. This is what really understanding is all about. Okay. Great. Okay, so let's have a look at this one here. Now, this time we're multiplying the fractions. So just in case we have difficulty with this, imagine we have a fraction like a over b multiplied by c over a or something. Well, we can just multiply the two numerators, that's ac over ba. And then, you can always flip that around and AC over AB. But basically, we see the A is on the top and bottom, so we can just cancel it out. Or if we had 2/3 multiplied by 5 over 2, we see that the 2's cancel. So we know that will give us like 5 over 3. So what we're having to do here is just basically see that this x plus 1 is appearing as a numerator in this one. Well, this is maybe a bad example. I probably should have made it. Let me just change this. This should probably be something else. Sorry, I made these examples up, but let's make that into a 2. That's what it should have been. Sorry. And we see that x plus 1 is appearing here, and then we can cancel it off, and then we'll just have like x plus 2 over x minus 1. I'm not too sure why I called it conjugates. Now, this is true. Basically, and you don't have to do this double F thing, but just basically if x is not equal to 1. You may see sometimes, like when I'm writing down a solution, I have a kind of a funny symbol like this or something like that. You can always write out your sort of additional little things you have to write down. You can always write that out in English. Like if you were doing an exam and you said, as long as x is not equal to 1, because, and then you went on to write an essay about this. Like, you're not wrong. You're just taking more space than you need to, but it doesn't matter. Do you know what I mean? Like, this is kind of how to kind of do it in the most efficient way. But the last thing that you're going to don't worry about efficiency exactly. Right? You have to be You have to put down correct answers. Like putting correct answers down that are also efficient. I mean, who cares? That's like kind of worrying about having perfect handwriting or something. It's not really going to make a difference to your grade, right? It just whatever, it just is more, it's whatever, nicer to do it that way. So you can always write down a sentence in English if you're not comfortable. Like if you want to explain it, you can always do that. You'll get the marks if it's correct. Okay, so now we come to solving equations. And what we're going to be using when we do this is the previous tricks. Usually, sort of what we want to do is if we're going to have an equation, which would be like, let's say we took this one and we said, like, this one here, let me just sort of take this, I'll take this to a new page. So let's say we had this one here, and let's say it was equal to 5. Our first step would have to be to combine this into 3x plus 1 over x times x plus 1 equal to 5. Like what we would want to do is get one fraction. This is one fraction, and this is okay. It doesn't look like a fraction, but 5 is the same as 5 over 1. We want to get one fraction on both sides. And the reason why we want to get one fraction on both sides is then we can multiply things up, we can multiply things across. We're able to say what's multiplied on one side is divided on the other side. What's divided on one side is multiplied on the other side. And then we can get everything up above the line. We're not dealing with fractions anymore. And we can bring everything over to the left-hand side. And then we'll just have an equation like a linear equation or like a quadratic equation. So this question here starts off as an algebraic fraction question. And then it turns into just a question like solve an equation. And this is also really good news for you guys because this is a more difficult question, but the difficulty is because it's an algebraic fraction question plus another thing that you already know how to do. So they don't make a new difficult thing by having something brand new. It's only half new. And that's what happens again and again in the course, which is why with maths, it's always, if you can understand what you're doing and you're not just remembering stuff, you really benefit from that. Okay, so what I'm going to do here is I'm going to realize this is a fraction on this side, this is a fraction on that side. So I'm going to multiply. So what's multiplied on one side is divided on the other. What's divided on one side is multiplied on the other. And I'm going to get, my objective is to get everything above the line. So the only thing that's causing me a problem is that denominator. And so I'm going to move on to the next line. Implies x plus 1 is equal to 2x. Okay, we're almost there, but I want to kind of gather together like terms. So if I had numbers and x's, I want to put them all together. So let's bring everything to the left-hand side. So x plus 1 minus like 2x is equal to 0. And then like minus x like plus 1 is equal to 0. And then we can say like minus x is equal to minus 1. And then we multiply both sides by, x is equal to 1. Okay. And that's our answer. If and only if what? If and only if what? Have a think about it. X is not equal to, what can x not be equal to in this situation? And in order to answer this, you need to look at the fraction. In particular, you need to look at the denominator. You have to say, we're never allowed to divide by 0. X is not equal to 0 in this case. If it was equal to 0, we wouldn't be able to multiply this up. So it's like x is equal to 1. Well, okay, I know what you're saying here. I have said x is equal to 1, even only if x is not equal to 0. That's kind of a little bit sort of silly. Let's just sort of take this and move it up here. You see, we're only able to make this step if x is not equal to 0. And then as long as x is not equal to 0, then we find that x is equal to 1. Okay, doesn't matter. Okay, so same thing here. So immediately what we're doing is we're taking x plus 2 and we're taking this x minus 1 3 times x minus 1 and we're multiplying it up. So that's x plus 2, and now I have to multiply our brackets. So 3 times x and minus 3. Now I'm going to bring that, let's bring everything over to let's bring all of the x's to the left-hand side, all the numbers to the right-hand side. So I've got x minus 3x. I forgot that write down implies. Sometimes I just go back and I just sort of fill them in at the end. Minus 3, like minus 2. This is like minus 2x is equal to minus 5. X is equal to minus 5 over minus 2. And then we find that x is equal to 5 over 2. And of course, we were only able to make this step if basically if x is not equal to 1, then we can do this step. Okay, so let's have a look at this example here. This time we don't only have a denominator on the left-hand side, we have a denominator on the right side. So we have a fraction on both sides. What we're going to do now is multiply. So this will be x squared equal to 2 times x plus 1. This will be x squared equal to 2x plus 2. This will be x squared minus 2x minus 2 equal to 0. We'll try and find two numbers that multiply to give us minus 2. To add to give us minus 2, we're not going to be successful. So this method is not going to work. So then we're going to have to say, well, if I want to solve this, I now need to use the quadratic formula minus b plus or minus the square root of b squared minus 4ac all over 2a. So this will be, in our case here, we'll have like a is equal to 1, b is equal to minus 2, and c is equal to minus 2. So we would sub those numbers in and we would keep working and we would not make any mistakes with minus signs and so on. And then we get to an answer at the end where we have x is equal to one thing and x is equal to a second thing. Now I'm going to talk about this probably more tomorrow in the next lesson. But what I've done here is I haven't exactly been lazy in not finishing off the question. What I've done is I've sort of shown you like, okay, how to go about solving this problem. Okay, now we're on the road to solving it. Now we know exactly what we're going to do. And the rest is just filling it in, basically. Now, this rest of just filling in, it can actually take a little bit of time. But I'm going to make this point again, but this is like, it's like a different mode. Like here, we're really like, what's going on? You have to really be kind of thinking and maybe testing stuff out and maybe crossing something out if you're wrong and restarting with something else. So this is a kind of a creative type of phase of the problem. But this stage here is much more sort of robotic, right? And it's not to say that it's, you know, to use a negative idea. It basically, when you're doing this part, you need to know that you have been or have feel completely confident that you have been completely correct up to this point, basically. And it might happen that you're like, you know what, this is to get to the threshold of 10 out of 10. And here, you know that you already have 7 out of 10 because you've done these steps and you know the right method. And you're basically, I call this the home straight. But you might just want to leave it at 7 out of 10 because you mightn't have enough time left in the exam. And you might be like, you know what, I can get to 7 out of 10 on the last question. So I'm not going to bother spending 5 minutes doing these careful calculations to get to the 10 out of 10. I'm not telling you to do that, but I'm telling you that, like, essentially, be aware of where you get the majority of the marks and just be prepared to basically, you know, maybe stop it then, or realize that if you go into the next stage that you're going to have to be in not in a creative state anymore, much more sort of robotic. Just so it's like changing gears in a car. There's an appropriate gear to be in at any moment. There's an appropriate sort of way to be thinking when you're doing, depending on which part of the maths problem that you're dealing with. Okay, so okay, great. So we want to talk about, let me just talk about kind of, I'll talk about graphs just for a moment. So let's just think about this for a second. So we have graphs, and the first thing that you learn at the graph is just a straight line. And the line is like y is equal to mx plus c or something like that, right? And then after that, we go and we graph quadratics, ax squared plus bx plus c. And that always looks like a U shape or an N shape, a U shape. or an n shape. After that, we've got y is equal to ax cubed. We have cubics. And the cubic will look like this. And what you realize here is I basically say this has got no bumps. This has got one bump. This has got two bumps. If we do a y is equal to ax to the power 4 graph, we'll get 1, 2, 3. Then we'll get 1, 2, 3, 4, 1, 2, 3, 4 for an y is equal to ax to the power 5. Okay. Then if we do something like y is equal to sine x, for example, we're going to get something that's wavy. There's all these fancy things. Sometimes you can get graphs that look like this. They go start down like this, and then they go like this. They just go like an S. This is called like an S curve. It's like I can't even x over. I don't know. I can't even remember what it is. But the reason and another one that we're going to talk about right now is ones that do something like this. Like they sort of go along like this, and then they take off and they shoot up into space, basically like this, and so on. Now, why am I showing you all this? And the reason why I'm showing you all this is because maths is basically used to describe things in nature, if that makes sense, right? Like you're making a model of something in nature. Like maybe it's the tides, right? Like, so you notice, every day you're like, here's time on the x-axis. This is the height of the tide. It goes up to the high tide, and it comes down to the low tide. And you say, how can I describe this type of behavior? Well, a y is equal to sine x curve would give you a description of that kind of behavior. Or you might be looking at, here we have a cannon and we fire a cannonball up in the sky and it goes like this and it traces out this sort of arc like this, right? And you're like, what kind of function can give me this type of shape? It turns out y is equal to, well, with the minus ax squared plus a quadratic would give you that. And so what we're doing when we do these things is we're sort of like noticing something in nature and we're trying to come up with a model to describe it. And then that's why we would choose maybe a line, or we might choose a quadratic or something like that, okay? Now, where algebraic fractions come in is with these things called asymptotes. And I think probably the easiest thing is to take an example. So let's take the example of like y, let's just take this one here. Y is equal to 1 over x. Okay, so if I have x is equal to, let's try this. X is equal to 5, y is equal to 1 over 5. X is equal to 4, y is equal to 1 over 4. X is equal to 3, y is equal to 1 over 3. X is equal to 2, y is equal to 1 over 2. X is equal to 1, y is equal to 1 over 1 is equal to 1. X is equal to a half. Y is equal to 1 over a half. 1 divided by a half, you invert and multiply, it's 2 over 1, it's 2. X is equal to a third, y is equal to 3. X is equal to a quarter, y is equal to 1 over 1 over 4, which is 4 over 1. X is equal to 1 over 5, y is equal to 1 over 5, which is 5. Now, what I'm doing here, you see what I'm doing for the x. Let's just draw an xy axis. So this is my 5, 4, 3, 2, 1, 1, 2, 3, 4, 5. So what I'm doing with the x is I'm starting out here at 5, then I'm going 4, then I'm going 3, 2, 1. And you see, then I'm going a half, a third, a quarter, a fifth. I'm getting in here. I'm going in here towards the, see, I'm going in here towards the 0. I'm going towards, x is going towards 0. X is never going to be equal to 0. These are called limits, okay? We'll talk about these another time, but there's a difference between something actually landing on the value of x is equal to 0, or x getting this arrow here means it goes towards 0, gets infinitely close to being 0 without being equal to 0, right? So, sorry, I forgot to put the line on. Okay, so that's what's going on here for the x. We're starting at 5 and we're going down. We get closer and closer in. What happens for the y at the same time? So these are all the input ones. 5, 4, 3, 2, 1, a half, a third. a quarter, a fifth. What's happening with the y at the same time? Well, it's starting at 1/5. It's going to 1/4. It's going to 1/3. It's going to 1/2. It's going to 1. It's going to 2. It goes to 3. It's having the opposite type of behavior. While the x is like a seesaw, while the x is flying in towards 0, the y is doing the opposite thing. So this here is 1, 2, 3, 4, 5. So let's go and plot the points, and then we're going to see what I'm talking about here. So when x is 5, y is 1/5. It's right there. There's 1/5, like in between. There it is there, right? When x is equal to 4, it's 1/4, just slightly bigger. 1/3, 1/2, 1. And then when x is equal to 1/2, it's 2. When x is equal to 1/3, it's 3. 1/4, it's 4. Like this, 1/5, or something like this, right? And so we get a shape that looks like this. And the funny thing is that if we take this shape here, and if we were to do exactly what we were doing, sorry, if we were to do exactly what we were doing, oh, sorry about this, except with negative numbers, we'd find actually this thing happening here. Okay. So what we have this, so we were talking about, I was talking about functions and stuff like this. And I was saying sometimes you might want a straight line, sometimes you might want a curve with one bump, a curve with two bumps, a curve with many other bumps. Sometimes you might want something that goes up and down like tide. Sometimes you might want an S curve, like in circuitry, if you're only doing physics, S curves, you care about these things. Sometimes we want asymptotes, because with asymptotes, what you have is you have these sort of weird sort of fences. I always sort of think of them like as a field. You see, they have these fences. These are called the asymptotes. They're either vertical or horizontal lines, and the curve is never allowed to cross them. And a lot of these questions will be to find the vertical asymptote. But where's the vertical asymptote happening? You just look at the bottom of the fraction. You say x is equal to 0. That's where the vertical asymptote happens. So you can just draw the vertical asymptote. And then the horizontal asymptote is just a little bit more work. I don't know if you really asked for that. Okay. So why this long discussion? Why this long explanation? What we want to be doing when we study maths is we have something like this algebra stuff, and you can do things like factorize and find numbers, and it's nice. Okay, well, that's great. But what we want to always be able to do is link it to some kind of picture, and then link that picture to some sort of behavior that maybe that we care about. Now, why is this kind of important? And the reason why it's important is that brains are often just a lot better with pictures, because pictures are tangible. You can kind of look at them. And if you're able to connect some abstract concept like algebra, quadratics, factorization into something that works with a picture, for example, roots from yesterday, it just means that it really connects it to your understanding, because it's a real kind of thing that you're talking about. So in this case here, if we wanted to make graphs of algebraic fractions, this is the kind of thing that they look like. They look like these sorts of like a rocket taking off, or something plunging into like straight down, or it maybe sometimes you might think of an airplane coming into land or something like that. You're basically talking about a curve that will run along these lines either vertically upwards or horizontally, right? And then you might have the question is like, when like does this sort of line here that's going along here, like does it ever actually hit the ground? Like, does the airplane ever land? And the answer to that question is actually no, it just skims the ground until infinity, right? So that's kind of where we can get into the concept of things like limits and stuff, which we'll see later with calculus and stuff. Okay, so we can move on now. That was my graph paper that I ended up not using. Okay, so just while we're here, have a go at some of these questions just for a few minutes, and I think we can then have a look at some exam questions just as a little bit of a. And if you have any questions, also now is a good time to put any questions into the chat, and I can just sort of speak to one of you kind of directly, while everyone else just takes a few minutes just to work on these examples. Okay. Well, maybe I'll give it another minute. Okay. Let's just do them real quick. So x squared minus 5 squared. So that top line is the difference of two squares because it's an x squared part. There's a number, there's not another x here, and there's a minus, and we can see that it's a square, right? So that's x squared minus 5 squared. And the bottom line is two sets of brackets. Okay, two numbers that multiply to give us x, two numbers that multiply to give us 25, and that add to give us minus 10. Well, I'm going to say 5 and 5, and I'm going to say minus and minus. You see what I said there? I said we're gonna take 5 and 5, and we're gonna take minus and minus. I separated it into two different things. No matter how long you've been doing this stuff, you can always trip up over your own feet in a moment like that. So that's why it's good to always break it down into bite-sized pieces, right? So now we have incidentally, that's a perfect square. So we have the top line is x minus 5 over x plus 5, and this is x minus 5 times, sorry, x minus 5 times x plus 5. I'm not too sure what I said there. And then x minus 5 times x minus 5. And then we can go ahead and cancel off this one. And that's my answer. If and only if x is not equal to 5, because then we would be dividing by 0, and this doesn't work. Okay, so let's go ahead and so we're going to combine fractions here. I have to put a number here. So I have to put a fraction here and a fraction here. I'm going to multiply by this fraction, this first fraction, by something over itself. I'm going to multiply the second fraction by something over itself. And the answer is the other denominator. And notice what I've kind of done there as well. Like I've kind of not given myself the task of just launch. It's like climbing, you know what I mean? Like it's like if you're climbing up a cliff or something like that. You're not going to try and reach for it like too high above you. You just proceed in like smaller steps and just break it down into something that's simple. You want to make everything simple and not strenuous, right? Okay, so we have now the top line here, 3 times x plus 2 plus, and then 1 times x is just x plus x. And then it's going to be x times x plus 2. And then we multiply this all out, and it's going to do it super quick. 3x plus 6 plus x all over x times x plus 2. And then this is going to give me I just want to rub out that top line because I'm running out of space. Where is it? Well, 3x and x will be just 4x, okay? Four x plus 6, and now we're done. We could even factorize out a 2 from the top line if we wanted to. So 2 into x plus 3 over x times x plus 2. So now we're done. Okay, so this one here, we're going to cross multiply. So that implies that 2 times x plus 1, don't forget the brackets, is equal to 3 times x. That implies that like 2x plus 2 is equal to 3x. We're going to bring the x's across to the left-hand side. bring the numbers across to the right-hand side. So I have 2x minus 3x is going to be minus x is equal to minus 2, and then multiply both sides by minus 1, then x is equal to 2. Okay? And we can do that as long as, like, see, this thing here doesn't work if x was equal to 0, then we would have a problem. So x can't be equal to 0, and if x was equal to minus 1, then we have a problem as well. So sort of even before we begin, we have to say, well, look, we're going to rule out these two. Okay, maybe we can maybe talk about this a little earlier. And now they want to talk about a graph of the algebraic function, algebraic fraction, like what this function here, if we write it as y is equal to this thing here. What kind of picture does it give us? So these things, as I said, like, you know, quadratics are U-shape, linears are lines, cubics have like a kind of a like an S type of shape, right? These things have this thing where they have like this, like, let's say I draw the XY axis. We have these lines like asymptotes, and they go like, I'll do it in a different color. They kind of, the asymptotes sort of contain the curve. They don't cross these lines called asymptotes. Okay, so how do we find them? Well, the horizontal asymptote, first of all, you have to look like, where is y going to go to infinity? And where y is going to go to infinity is when the bottom of the fraction, basically the denominator, is equal to 0. So that's when x minus 2 is equal to 0. So that's when x is equal to 2. So this one here for this function is x is equal to 2. That's the position of the vertical asymptote. And what about this one here? This one here is a little trickier to find. But what you have to say to yourself here is like, oh yeah, I'm going to mess this up a little bit. Need something here. Sorry. Didn't intend that for me to move my graph. We'll just do this one super quick. I'm not too sure exactly if you're asked for this. Okay, so this is my y-axis, this is my x-axis, okay? And this is my, sorry about this. Sorry, I should have done this more carefully. So this is there, that's my x is equal to 2 on my x-axis. Here's my x-axis. There's x is equal to 2. That's where the vertical asymptote is. What about the horizontal asymptote? So what we have to do is we have to look at this fraction here, x plus 4 over x minus 2. And we have to think about what happens when x tends to infinity. So you see, as we go out this direction here, as we go along the x-axis, we can see that this asymptotic line is getting closer and closer. Sorry, this curve here is getting closer and closer to the asymptote. Okay, and then if we know what x is getting closer and closer to, we're going to know what value where that happens. And it's just a quick trick. What we're going to do is just like a tiny trick. I'm not too sure if you actually do it, but just while we're here, we'll just do it quick. I'm going to multiply top and bottom by 1 over x. And this is going to give me 1 plus 4 over x over 1. Oh, I even drew this incorrectly. Okay, doesn't matter. Kind of mess this up. Anyway, so now basically here, as x tends to infinity, we're going to get 4 over much larger number. Whereas 2 goes to infinity, we're going to get 2 over much larger number. They're both going to disappear. So this thing is going to actually only be left over with this one here. So y is going to be equal to 1. I'm not going to get too much into this because it's just, but that's how we go and find out where the where the horizontal asymptote is. But I think we only really want to think about the vertical asymptote for now. We'll come back to this another time. Okay, so in the last 10 minutes now, I want to look at some exam questions. We'll just do a few of them, and I think we'll have enough time for this one here. Okay, so you'd be amazed how much just the fact that we suddenly plunged into using t instead of x can throw you. And what I have to say to you is that if you kind of understand what you're doing, this shouldn't throw you, because there's absolutely no difference with this. Okay, so what do we need to do? We need to multiply the first fraction by something over itself, the second fraction by something over itself. What is this? What is this? What's going to go in those two places? Then it's going to be 12t and 12t, put brackets around that one. And then it's going to be 2t plus 1 and 2t plus 1. Okay, so all I've done is I've modified the two fractions by multiplying the one on the left by this other denominator. Now I've got 48t on the top line, and we're just going to have one big line, 12t times 2t plus 1. And then I'm going to have minus 7 times 2t plus 1. And this is going to give me 48t minus 14t minus 7. 12t, 2t plus 1. This is going to give me 34t, because 48t minus 14t will be 34t minus 7 all over 12t, 2t plus 1. No matter how long you spend doing maths, you can always make mistakes with mind signs, so you just have to slow it down. So let's have a look at the marking scheme for this. So as I say, you know, top marks are 10, no marks are 0. So doing nothing gets you nothing, getting everything perfectly correct. What about the low partial credit? So work of merit, for example, identifies the numerator or the common denominator. Like, if you do any bit of this correct, like if you sort of took the first one and you did this or something, like you're kind of, it's a very, very low bar to get this thing here. They just want to see something, like some kind of indication that you may be starting off going in not the completely wrong direction. Okay. And then you're up at the 4 marks out of 10. And then for the high partial credit, you have to have gotten to this stage here where you've sort of, you know, basically done the step of combining. So you have to have gotten to sort of this point here and maybe stopped. Now, like, you know, it is a kind of an idea that actually, you know, you could go through the entire exam, get to this stopping point at the 6 or 7 marks out of 10, and then get to the next question. You know what I mean? Instead of getting bogged down, and do you know what I mean? Like, it'd be better to get a whole bunch of 6s or 7s out of 10 than it would be to get just a few 10 out of 10, if that makes sense. Not that I'm telling you to do that. I just want to kind of give you that kind of context. And then full credit minus 1, basically, if the numerator is simplified correctly with an incorrect. So if we made a mistake in the denominator or something like that, I think then, yeah, so even if you had this line here and you put a 3 here or something, you still get 9 marks out of 10. Okay. So let's have a look at this second example here. So again, this time we're back to using x. And we want to write it as a single fraction in its simplest form. Okay. So we have to choose a number to put here and here, and it's the other denominator, so x over x. And we have to choose a number to go here and here, it's 3x minus 5. Let me just put that in brackets. So once we have, now we have the same denominator, right? So x times 3x minus 5 is denominator here. X times 3x minus 5 is the same denominator here. So what we're going to do now with this is we can combine it into one fraction. And we can write down x times 3x minus 5. And then the first one is like 2 times x. And then the second one is like, that gets people. So like what to do with that minus? Well, what we do is we just like, you can have minus 6 over x, or you can have, sorry, you could have like minus 6 over x, or you could have like minus 6 over x, right? So the minus can go up into the numerator. So we just have to put that minus up into the numerator, and then it's like 6 times 3x minus 5. Now, having done something like this here would be the low partial credit. You get a sense of, after you have a look at enough of these ways in which they grade it, we get a sense of where we are. Like if you were like, look, I have no idea how to do this question, probably that's there. Let me just write that down and move on because I don't like this question. You've just given yourself 3 marks out of 10, which is like, this is what it's about. It's about accumulating. As when you don't know the answer, it's like, okay, I have to maximize. I have to get as high a partial credit as I can in the least amount of time. That's actually that's the task here, right? So if you knew nothing, then just simply writing that down is enough to get 3 marks out of 10. That's good to know. Okay, now having written this down, we're already at the 7 marks out of 10. And now what I'm going to do is continue on with this. So this is like 2x minus 18x. Super careful. Minus and minus is plus 30. Now you might say you'd never make a mistake with that, and you'd be amazed how often you make a mistake with that. I make mistakes with that like all of the time. And I just say it's because I've been doing this stuff for years. You're never immune to making a mistake like that. We're also not going to multiply out the bottom line because they're talking about the simplest form, right? And if we're given something that we can factorize, we factorize it. So why would we multiply this thing back out again? If it was 3x minus 5 plus another thing, yeah, then we would have to multiply it back out and maybe factorize it again. But it isn't. It's already in its simplest form, so we're going to leave it like that. And this is going to be equal to, I give myself a line again. Two x minus 18 plus 30 is going to be plus 12 over x times 3x minus 5. And then the top line 2, and then x plus 6 over x times 3x minus 5. Do you have to do that last line? Well, just sometimes it happens that you can actually even, do you know what I mean? You can actually even cancel further. It could have happened that this was 3x minus 5. Then we would have just been left with that, right? So now we're done. We can't go. We've written it as a single fraction in its simplest form. When I'm here at the end of the question, I'm revisiting, like I'm saying, I think I answered the question, did I? And the only way to know if you've answered the question is to actually reread the question. So you always have to reread the question at the very end. It might happen that you're like, oh, I did totally the wrong thing. And like, now I don't have time and I've got to move on. In that situation, like if you just misread the question and you did some stuff, it's also helpful to notice, well, you've gotten your 3 marks out of 10 for this one, and you've gotten your 7 marks out of 10 for that one. So, okay, it's a bit of a disaster, but I did the wrong thing, but I'm still getting most of the marks, so we can just move on if we have to. Otherwise, just sort of start again. It might happen that you're running out of space on the paper. Ask for more paper, okay? The exam, when I did it, you could just have as much paper as you wanted. Now they give you an amount of space. Just ask for more paper if you need it. Don't hesitate to do that. Okay, just time to do one. Oh yeah, sorry. So then the low partial was finding a common denominator. So if we just found this piece, we would get the low partial credit, and the high partial credit was getting to that line, which was the 7 out of 10. Okay, so what we have now, this is the last one I'll do, and I'll quickly, so I'll just do this as quick as we can. We have a combination of two of the ones we were doing before. See, if we go back and I would just look at the homework thing that I gave you, we had a bit where we were like combining two fractions, and then we had a bit where we were solving an algebraic fraction, an equation with algebraic fractions. So this time we have actually two of them, right? We have two different fractions here on the left-hand side, and they're in an equation with that. How do we do this? Well, we just take it a step at a time. Let's first of all look at the left-hand side. So I'm just writing down the right-hand side. I'm not doing anything with the right-hand side besides writing it down. And now I'm going to take that first fraction, 3 over 2x plus 1, and then 2 over 3x minus 1, right? And I have that plus sign there, and now I'm going to just multiply, okay, something here, and I am running out of time, so I don't think I'll be able to finish this. Sorry, what did I say that for? It's not, I don't know where I got that from. This is a 5. Okay, so now I'm going to take, okay, so what do I multiply here and here on this first fraction? The other denominator. And then this is 2x plus 1. This is 2x plus 1, the other denominator. So now if I go ahead onto the next line, I'll say implies, and then I'll have one big line equal to one big line. Then I'll have like 5 times 2x plus 1. Okay. Then I have 15 plus, and then 2 times 2x plus 1 is again equal to 2 over 3x minus 1. Then this line here is like 15 plus 4x plus 2. So what do I just, that was a plus 1. So yeah, plus 1. So why don't I just say 4x plus 17? And then over 5 times 2x plus 1 is equal to 2 over 3x minus 1. And now I'm basically finished the first stage of this, which was to combine this left-hand side into one single algebraic fraction. So that stage is finished. Now I go to the second stage, and this is where I'm going to say, I'm going to get everything up onto the top line. So this one here is divided on the right-hand side, so it's multiplied on the left-hand side. So you go across 3x minus 1. And then on the right-hand side, it's 2 times 5, which is 10, times 2x plus 1. And you know what? I'm going to multiply this out. I'm going to get a quadratic. I'm going to multiply this out. I'm going to get more things. Basically, I've boiled it down to solving a quadratic equation. Now, another couple of things is they ask these questions, and then they have extra little notes that they stick on. So this is the question, but they have these extra little notes. And just consider, why are they saying this? And they're saying this as well, right? But why are they saying this bit? Because if x was equal to a half, this one would be 0, so we would be dividing by 0. If x was a third, then so basically this question only makes sense if we rule out these. X is not allowed. These are like trapdoors sort of thing. Everything breaks, right? So we just have, in order for this question to be strictly correct, and we're doing the Lebenspseudo, everything has to be perfect. They have to give this little extra piece of information, right? So then for the thing, it's like basically we would get to, if we got all the way down to a quadratic. So once we multiply this out, we'll get a quadratic. So if we get a quadratic here, that's when we get the high partial credit, which is 11 marks out of 15 here. And if we got to here, the equation without fractions, we would get the mid partial credit, which is 7. Okay, I've got to finish there because my next lesson's starting. So hopefully that's helpful. And then tomorrow we're going to do coordinate geometry, and yeah, I'll see you then.